For a long time, scientists assumed most planets would probably look similar to the ones in our own solar system, rocky worlds like Earth or Mars, or large gas giants like Jupiter and Saturn. But once astronomers started discovering planets orbiting other stars, that assumption quickly fell apart. The universe turned out to be filled with planets that behave in ways we never expected. Some planets are so close to their stars that their atmospheres boil. Others are colder than anything found in our solar system. Some are darker than coal, while others may contain oceans of lava or layers of superheated ice. Over the last few decades, astronomers have discovered thousands of these distant worlds, called exoplanets, and some of them are among the strangest objects ever observed in space. These discoveries have forced scientists to rethink how planets form, how they evolve, and what kinds of environments can exist in the universe. To understand just how bizarre planetary systems can become, we're going to explore some of the weirdest planets ever discovered, starting with one where the weather forecast includes metal falling from the sky. WASP 76b, the planet where it rains iron. Roughly 640 light-years away from Earth, orbits one of the most extreme planets astronomers have ever studied. WASP 76b is classified as an ultra-hot Jupiter, meaning it's a gas giant similar in size to Jupiter but located extremely close to its star. In fact, the planet completes a full orbit in only about 1.8 Earth days. Because of this incredibly tight orbit, the planet is tidally locked, which means one side permanently faces its star while the other remains in darkness. This creates an enormous temperature difference between the two halves of the planet. The side facing the star reaches temperatures above 2,400 degrees Celsius, which is hot enough to vaporize metals like iron. Instead of remaining solid, iron in the atmosphere turns into gas. Powerful winds then carry this metal vapor toward the cooler night side of the planet. As the gas cools, it condenses back into liquid form. Scientists believe this process creates a bizarre type of weather, molten iron rain falling through the atmosphere. Winds on WASP 76b may reach speeds of up to 18,000 kilometers per hour, constantly transporting heat and material around the planet. The result is a violent atmospheric system where metals evaporate, travel across the planet, and then fall again as liquid droplets. No solid surface has ever been observed on WASP 76b, but the atmosphere alone makes it one of the most extreme environments known in planetary science. GJ436b, the planet with burning ice. About 33 light-years away from Earth is another strange world that seems to break basic rules about temperature and matter. GJ436b is often described as a hot Neptune because its size and mass are similar to Neptune in our solar system. However, unlike Neptune, this planet orbits extremely close to its star and completes a full orbit every 2.6 days. Temperatures on GJ436b are estimated to reach around 430 degrees Celsius, which is far hotter than the temperature required to melt ice. But despite these conditions, scientists believe large amounts of water inside the planet exist in a solid form known as superheated ice. This happens because of enormous pressure deep inside the planet. Gravity compresses the water so strongly that the molecules cannot expand into steam, even at extremely high temperatures. Instead, the water forms exotic crystal structures called Ice 7 or Ice 10. These are forms of ice that can exist at temperatures far above the boiling point of water on Earth. Essentially, the planet may contain ice that is hotter than lava. Observations also show that GJ436b is losing its atmosphere over time. Radiation from its nearby star is slowly stripping hydrogen gas away from the planet. This escaping gas forms a massive cloud trailing behind the planet, giving it a comet-like tail stretching millions of kilometers into space. Over extremely long timescales, this process could dramatically change the planet's structure as its atmosphere continues to escape. TRES 2b, the darkest planet ever found. While some planets reflect large amounts of light from their stars, TRES 2b does the exact opposite. This exoplanet is considered the darkest planet ever discovered. It reflects less than 1% of the light that reaches it, making it darker than charcoal or black paint. TRES 2b orbits a star located about 750 light-years away from Earth and belongs to the class of planets known as hot Jupiters. Like many planets in this category, it orbits extremely close to its star and completes a full orbit in just a few days. The planet's atmosphere reaches temperatures around 1000 degrees Celsius. At these extreme temperatures, reflective clouds like those found on Jupiter cannot form. Instead, the atmosphere likely contains vaporized chemicals such as sodium and potassium that absorb incoming light rather than reflecting it. Because of this, nearly all of the star's light disappears into the planet's atmosphere instead of bouncing back into space. Despite being extremely dark, TRES 2b isn't completely invisible. Its high temperature causes the planet to emit a faint reddish glow, similar to how heated metal glows when it becomes very hot. This faint thermal radiation helped astronomers detect and study the planet using space telescopes. J1407b, the planet with rings larger than a solar system. If you think Saturn's rings are impressive, J1407b takes the concept of planetary rings to an entirely different level. Located about 434 light-years away, J1407b is believed to host the largest ring system ever observed around a planet. Scientists estimate that the rings may stretch up to 120 million kilometers across. For comparison, Saturn's rings extend only about 280,000 kilometers from the planet. That means J1407b's ring system could be hundreds of times larger. If these rings replaced Saturn's in our solar system, they would appear many times larger than the Moon when viewed from Earth. The ring system is also incredibly complex. Observations suggest that it contains dozens of individual rings separated by gaps. These gaps may have formed because young moons are developing inside the ring system. As these forming moons orbit the planet, their gravity clears paths through the surrounding ring material. In other words, J1407b might provide scientists with a rare opportunity to observe the early stages of moon formation in progress. Over millions of years, much of the ring material may eventually combine into fully formed moons. But for now, the ring system remains one of the largest and most spectacular planetary structures ever detected. PSR B1257+12, the Dead Star Planets. One of the strangest planetary systems ever discovered doesn't orbit a normal star at all. Instead, it circles a pulsar called PSR B1257+12, located about 2,300 light-years from Earth. A pulsar is what remains after a massive star explodes in a supernova. When the star collapses, it forms an incredibly dense object known as a neutron star. These objects are only about 20 kilometers wide, but contain more mass than our Sun. As the neutron star spins, it emits powerful beams of radiation from its magnetic poles. When these beams sweep across Earth, astronomers detect them as incredibly regular pulses of radio waves. The discovery of planets around PSR B1257+12 in 1992 shocks scientists because pulsars are among the most violent environments in the universe. The system contains at least 3 planets that likely formed either from debris left after the supernova explosion or from material captured later. The surface of these planets would be completely hostile to life. Intense radiation from the pulsar constantly bombards them with high-energy particles. Instead of sunlight, these worlds would be illuminated by bursts of radiation from a spinning stellar corpse. Temperatures, radiation levels, and magnetic activity would make the environment extremely destructive for any kind of atmosphere or complex chemistry. These planets are historically important because they were actually the first confirmed exoplanets ever discovered, even before planets were found around normal stars like our Sun. Their existence proved that planets could form in places scientists never expected. HD 189733b, the planet with glass storms. About 64 light-years away from Earth lies a planet that might look beautiful from a distance, but would be unimaginably dangerous up close. HD 189733b is another hot Jupiter, a gas giant that orbits extremely close to its star. The planet completes an orbit in just over 2 Earth days, placing it so close to its star that its atmosphere reaches temperatures around 1000 degrees Celsius. At first glance, the planet appears deep blue, similar to Earth when viewed from space. However, this color doesn't come from oceans. Instead, it is caused by silicate particles in the atmosphere scattering blue light. These silicate particles are essentially tiny grains of glass. Winds on HD 189733b may reach speeds of more than 8,000 kilometers per hour. These extreme winds drive violent storms through the planet's atmosphere. Because of the high temperatures, the silicate particles melt and then solidify again, forming sharp fragments of glass. Scientists believe that powerful storms on the planet could send these glass particles flying sideways through the atmosphere. Instead of rain falling downward like on Earth, HD 189733b may experience horizontal glass storms, where molten or solid glass particles move through the air at thousands of kilometers per hour. Any probe entering the atmosphere would likely be destroyed almost immediately by the intense heat and abrasive storms. 55 Cancri E, the possible diamond planet. About 41 light-years from Earth is a rocky planet that may contain one of the most unusual interiors ever suggested by astronomers. 55 Cancri E is known as a super-Earth, meaning it is larger and more massive than Earth, but still composed mostly of rock. The planet orbits extremely close to its star and completes a full orbit in only about 18 hours. Because of this tight orbit, temperatures on the surface can reach more than 2000 degrees Celsius. At first glance, this might sound similar to many other hot exoplanets, but the planet's chemical composition may be very unusual. Early studies suggested that the planet could contain enormous amounts of carbon in its interior. Under the immense pressure inside the planet, this carbon might compress into crystalline structures similar to diamond. If this interpretation is correct, large portions of the planet's interior could consist of diamond layers or diamond-rich rock. While later observations have suggested the composition may be more complex than originally thought, the idea of a diamond-rich planet captured the imagination of scientists and the public alike. Regardless of the exact composition, the surface environment of 55 Cancri E would be extremely hostile. The side of the planet facing the star may contain oceans of molten lava, while the night side could be significantly cooler due to tidal locking. Kepler 452b, Earth's distant cousin. Not every strange planet is extreme because of deadly conditions. Some are unusual simply because they resemble Earth more than most other planets discovered so far. Kepler 452b is one of the most famous examples. Located about 1,400 light-years away, this planet orbits within the habitable zone of a star very similar to our Sun. The habitable zone is the region around a star where temperatures could allow liquid water to exist on a planet's surface. Kepler 452b is about 60% larger than Earth, making it likely a super-Earth. Because of its size, it may have stronger gravity than our planet. Scientists estimate that the planet could be rocky and may even contain active geology such as volcanoes or plate tectonics. Its star is slightly older and brighter than the Sun, meaning the planet receives somewhat more energy than Earth does. This could lead to a warmer climate, potentially similar to Earth during earlier periods of its history when the Sun was younger. While scientists cannot yet confirm whether the planet has oceans, continents, or an atmosphere, Kepler 452b remains one of the most Earth-like planets ever discovered outside our solar system. It shows that while many planets in the universe are extremely strange, some might still resemble environments where life could potentially exist. WASP 12b, the planet being eaten by its star. Some planets are strange because of what they're made of. Others are strange because of what's happening to them right now. WASP 12b is one of the most dramatic examples of a planet slowly being destroyed. Located about 870 light-years from Earth, WASP 12b is another hot Jupiter, but it orbits its star even closer than many other planets of this type. In fact, the planet is so close that a full orbit takes just a little over 1 Earth day. At this distance, the star's gravity stretches the planet into an egg-like shape instead of a sphere. The intense heat from the nearby star raises atmospheric temperatures above 2,500 degrees Celsius. At those temperatures, the outer layers of the planet begin to expand and escape into space. Astronomers have observed a massive cloud of gas being pulled away from the planet and spiraling toward the star. This process is known as atmospheric stripping, and over time it can slowly tear a planet apart. WASP 12b is essentially being eaten by its own star. The escaping gas forms a glowing envelope around the star-planet system, and scientists estimate that the planet may lose a significant portion of its mass over millions of years. Eventually, if the process continues long enough, the planet could be completely destroyed. Instead of remaining a stable world for billions of years like the planets in our solar system, WASP 12b may be living through the final stages of its existence. TRES 4b, the planet fluffier than styrofoam. Among the strangest planets discovered are those that seem almost impossibly light. TRES 4b is one of the most extreme examples. This planet is roughly the size of Jupiter, but has far less mass. In fact, its density is so low that scientists often describe it as being fluffier than styrofoam. Located about 1,400 light-years away, TRES 4b is another hot Jupiter orbiting extremely close to its star. The intense heat from the star causes the planet's atmosphere to expand dramatically. Instead of remaining compact like Jupiter, the atmosphere becomes puffed up and extended, making the planet far larger than its mass would normally allow. If TRES 4b were placed in water, it would theoretically float. While planets obviously cannot float in oceans, the comparison helps illustrate just how low its density is. One explanation for this inflated size is that radiation from the nearby star heats the planet's interior, preventing the atmosphere from collapsing inward under gravity. The planet's gravity is relatively weak compared to its size, allowing the atmosphere to stretch outward into space. Scientists are still studying these extremely low-density planets to understand exactly how they form and maintain such unusual structures. Kepler 16b, the real Tatooine. For decades, science fiction imagined planets orbiting 2 suns. But in 2011, astronomers confirmed that such worlds actually exist. Kepler 16b is one of the most famous examples. Located about 200 light-years away, this planet orbits not one star, but 2 stars that circle each other in a binary system. As the planet travels around them, the sky from its surface, if it had one, would feature 2 suns rising and setting. Kepler 16b is a gas giant similar in size to Saturn. It completes an orbit around both stars roughly every 229 Earth days. The 2 stars themselves orbit each other every 41 days, creating a constantly shifting pattern of light and shadow. Although the planet itself is likely too cold and gaseous to support life, its discovery proved that planets can form in binary star systems, something many astronomers once believed would be too chaotic for stable orbits. Today, scientists have discovered many more circumbinary planets. worlds that orbit 2 stars instead of 1. Kepler 16b showed that the universe is capable of producing planetary systems even more complex than our own. PSO J318.5-22. The rogue planet. Not all planets even have a star at all. PSO J318.5-22 is a rogue planet, meaning it drifts through space without orbiting any star. Located about 80 light-years from Earth, this object formed much like a planet, but somehow ended up alone in interstellar space. Rogue planets can form when gravitational interactions inside a young planetary system fling them out into deep space. Once ejected, they wander through the galaxy indefinitely. PSO J318.5-22 is estimated to be about 6 times the mass of Jupiter and is still relatively young in astronomical terms, around 12 million years old. Because it is young, it still glows faintly with heat left over from its formation. Without a nearby star providing energy, the planet exists in perpetual darkness. Temperatures are extremely low, and any atmosphere would be dimly illuminated only by the planet's own fading heat. Astronomers believe there may be billions of rogue planets drifting through the Milky Way galaxy. Some estimates even suggest they could be nearly as common as stars. These lonely worlds remind us that planets do not always remain tied to a star forever. The discovery of strange planets like these has completely changed our understanding of the universe. For most of human history, the only planets we knew were the 8 worlds orbiting our Sun. But modern telescopes have revealed that planetary systems across the galaxy can look very different from our own. Some planets are torn apart by their stars. Others are made of exotic materials or orbit 2 suns at once. And some wander the galaxy completely alone. Each discovery pushes the limits of what scientists once believed possible. As telescopes improve and more exoplanets are found, astronomers expect to uncover even stranger worlds, planets with environments that challenge our imagination and expand our understanding of how the universe works.